Kia ora koutou, Reese from QuickSense here, and today we're looking at the area of parallelograms and trapezium. In this question, we're asked if the rectangle ABCD, right, and that's A, B, C, and D, is equal to A, B, F, E. Now, the way to start thinking about this is how are they different? What's different between these? Well, the difference is really this little triangle in here, right? These are overlaps, as it were. And if they're the same, then this triangle, ACE, is equal to BDF, right? Because we can see that I have taken it away from my original rectangle, right? The original rectangle is this here, and the new one cuts this part out, but it adds this part here. So are they the same? Well, the things to look for here are the parallel lines. We've got two sets of parallel lines. These here, and we can tell because they have the double arrow, and these horizontal ones. Now, because they are the same, right, we can see that. I'm just going to draw this here. So this is my parallel line. This is the height of the original rectangle, and we can see that the height here is still the same as the height here. We also know that this parallel line, because it's still parallel afterwards, right, if we extend it out, if we shift it along, it's AE is the same as BF, right? So this is the same as well. And by the same logic, CE is the same as DF. So because of these parallel lines, and because that green triangle is being subtracted from the original rectangle, but then added to the parallelogram, the rectangle ABCD is equal to ABF. So the answer is yes. And the simplest way we can see that, because the green triangles have the same area. We can make it a little bit clearer. We subtract one green triangle from the original, rectangle, which is ABCD. Then add one green triangle. And as we all know, 1 minus 1 is 0. So therefore there is no difference. In this next question, we are being asked to find something out about a trapezium. Okay? And the best way to do this is to think about, well, firstly, what does a trapezium look like? Well, a trapezium has two sides that are parallel and two sides that are not parallel. So it's going to look something like that. So with this in mind, I'm going to start building up a diagram for myself. Now the distance between the two parallel sides of a trapezium is 10 meters. I'm going to start off here by just writing this down. And given that the area of the trapezium is 200 meters and that one of the two parallel sides measures 17 meters, what is the length of the other parallel side? Okay, so let's just draw an approximate trapezium here. remembering that this is that here, and I don't know, right, whether the bigger side or the smaller side is 17 meters, but I'm just going to write it, I'll write it at the top, just as a placeholder for the time being. Now the area a trapezium is equal to the average of the sides, so that's the top plus the bottom divided by 2, multiplied by the height. Now why is that? Well, if we look at this trapezium here, it almost looks like a rectangle. Right, we have the right angles here, and what we mean by the average is if I take the midpoint here, right, well, it's still going to be somewhere in there, and it's going to give me another rectangle. And the equation works because the part that's in here is equal to the part that's in here. Or I can add them together to make this rectangle here. So really the equation for the area of a trapezium is just a clever equation for the area of a rectangle. With this in mind, I know that one of my sides is 17. I don't know the other side. I know I'm going to find the average. I know my height is 10, and I know the area is equal to 200. So the first thing I do is I divide both sides by 10, which gives me 20 equal to 17 plus b over 2. I times both sides now by 2, so that 40 is equal to 17 plus b. Let's just finish over here. Now I take away 17 from both sides, which gives me b equal to 23 meters. So I was right, accidentally, right, to think that the 23 would be the longer side, and that the 17, which we see here, is the shorter side. So with all of this information, I was able to figure out the other parallel side at 23 meters.